What's up guys, welcome back to the channel. So in today's video we're going to be installing TrueNAS on this guy. This is the WTR Pro, AOOSTAR WTR Pro. I did create a quick walkthrough video of this device last week or so. So if you haven't seen it yet, link will be in the description box below if you just want to get a quick overview of what the device is. But in today's video, we're going to install TrueNAS on this guy. We're going to talk about the configuration. We're going to talk about TrueNAS to try to see if we can get a better understanding of what TrueNAS is. And we're going to talk about why I've decided to go with TrueNAS in the first place. Okay, so what exactly is TrueNAS? So TrueNAS is an open source storage operating system designed for managing and sharing data efficiently. It's built on FreeBSD and it uses the ZFS file system, which is known for its reliability, data integrity, and built-in snapshots. You might hear terms like core and scale thrown around. Now, TrueNAS core is the traditional FreeBSD-based version, while TrueNAS scale is the newer Linux-based version that introduced more flexibility, especially for containerization and clustering. Speaking of names, if you've heard the term FreeNAS before, that was the original project. It later merged into TrueNAS, with core being its direct successor. Now let's talk a little bit about containers. TrueNAS Scale originally uses Kubernetes for managing containers, but later switched to Docker to make things more lightweight and user-friendly. And yes, TrueNAS does support virtualization, letting you run VMs directly, on your storage system. And that's one of the reasons why I decided to go with it. If you're using core, you will also come across the term jail, which are FreeBSD's way of running isolated application, kind of like lightweight virtual machine, but more efficient. So why did I choose TrueNAS? Well, for me, it's an all-in-one solution, or it looks like it for right now, right? Because again, once I start playing around with it, I might run into some issues. But for now, it handles storage, virtualization, and Docker. This allows it to be like this all-in-one playground to learn and experiment on different concepts. And that's exactly what I need right now. I need a lab environment that is able to provide storage, virtualization, and Docker to allow me to be able to mess around with a lot of new concepts. Now, granted, I don't think, again, once I install it, I need to go in and start playing around with things, but I definitely don't think that the virtualization aspect of TrueNAS is as comprehensive as Proxmox, but it'll be great to be able to see what it's capable of and see if it's able to accommodate the things that I'm trying to do, or maybe I might need to set up another something like this just for Proxmox. But again, once we go in, they will be able to tell that. If I miss anything or you feel like you have insight to share for all of us to get a better understanding of TrueNAS, please drop it in the comment box below. It would help me and it will help anybody else that's going to come across this video. So I added two 1 TB NVMe SSD for performance optimization. One of the new SSD is going to be used for cache to help speed up read operation, and then the other one is going to be used for ZFS log to improve write performance and stability. One thing to keep in mind is that this device comes with a slot that can be used for Wi-Fi or Bluetooth if needed. However, it also includes an adapter that allows you to add another NVMe SSD, which I took advantage of. This one is the one that I was talking about. This one is supposed to be a slot for Wi-Fi adapter as well as or Bluetooth adapter, but it also came with an adapter to convert it to an NVMe slot. So I went ahead and used that. Pretty straightforward, pretty simple. Added a small form factor NVMe to it, so now I have 3 NVMe in total. What I'm thinking about doing is that the 1 TB SSD that came with the device is going to be used for the TrueNAS installation. The 1 TB is going to be used for cache, and then the other TB, which is the last one, is going to be used for the ZFS log. I don't know if we're going to run into any sort of issue when we go through the installation, but I guess we'll find out. But that's what's going through my head right now. We have 3 NVMe SSD, each of which is 1 TB, and it's going to be divided like that. And for now, it makes sense in my head, but once we go through the installation, we'll find out if we run into any issues. The idea is that this setup will help keep things running fast and efficient, which is exactly what I need. I also added 4 10 TB WD Red Plus HDDs, which are going to be used for, storage as well as the RAID setup. We'll talk more about the RAID configuration when we set up the storage pool later on in the video, because I also want us to get a good understanding of what RAID is, the different type of RAID that is offered in ZFS. So we're going to talk a little bit more about that later on in the video. I didn't increase the RAM. It still has 64 gigs of RAM. If I need to, I will increase that later, so I'm not too worried about that right now. Those are the upgrades that I made on the device. So now let's go through the installation process. Okay, so before we get started, there are two things that we need to do. First, we're going to need to download the TrueNAS SCALE ISO. We'll be using Scale and not Core, so we're going to need to download that ISO. And then two, we're going to need a USB drive that looks like this, because what we're going to do is that we're going to bond that ISO, the TrueNAS ISO, to this USB drive, and we're going to use this USB drive connected to our device and then boot from the USB drive so we can install TrueNAS. So in step one, let's go ahead and then try to download the TrueNAS SCALE ISO. So you can go to Google and then just type in TrueNAS and then click enter. And the link is the first result is basically the main website for TrueNAS. So you want TrueNAS SCALE. Again, I'm not doing Core. We've talked about what Core is and what Scale is. I'm going to do Scale and not Core. So I'm going to go ahead and click on TrueNAS SCALE. And it's going to bring you to the download page that will look something like this. If you scroll a little bit further down, you're going to see something here that says no thanks, because you can put in your email as well if you want to. But you say no thanks, no thank you. I've already signed up. Started there for a second. You can say no thank you, I've already signed up. Just click on that. And it's going to take you to the download page. A little bit of video here that tells you what TrueNAS SCALE is. There's a stable version and there's the beta version. I'm going to go with the stable version. So I'm going to go ahead and click download, and it's going to go ahead and do its thing. So if you see right here, it's downloaded and takes some time. And then the second thing that we need is Rufus. Rufus is what is going to allow us to bond the ISO that we're downloading right now to the USB. So same concept. You're going to go to Google and you're going to type in Rufus. RUFUS, and then click enter. And then Rufus is this guy right here. So you want to go ahead and click on the first result. And it's going to take you to the page. Again, Rufus is basically what's going to allow us to bond the ISO that we just downloaded to this USB. So if you scroll further down a little bit, you're going to see the download section. So let me scroll up, scroll up, scroll up. I scroll way too down. So as you can see, you have standard and you have portable. I'm going to go ahead and click standard. And that is also going to download. So once you're ready, you're going to run Rufus. When you run Rufus, it's going to look something like this. Again, it's pretty straightforward. Once you download, you just double click on it. And once you double click on it, it's going to run this program. So for the device, we want to select the device that we want to bond the USB, we want to bond the ISO to. So in our case, we want to use this guy, which is a 32 GB gigs flash drive. So that's the one that we want to use. If you have several flash drive installed, it's going to show you all of that, all of those options. Just make sure you select the right one, because once you install something on this flash drive, it's going to completely wipe it out. So just keep that in mind. And then from here, we want to select, say, hey, we want to bond an ISO. We're going to select that ISO, in our case, TrueNAS. We're going to see the name right here. So it's TrueNAS SCALE 24.1.10.2. That's the latest version. That's the one that we just downloaded. And that's pretty much it. So select the device and then select the ISO. And then when you click start, there are a couple of things that are going to come up. So the prompt that's coming up right now is going to ask you two things. Hey, do you want to bond this stuff that you selected, ISO that you selected as a ISO and image, or do you want to bond it as a disk image? What I found is that when I do ISO image, it doesn't work. I run into issues. So make sure you select write in DD image, which is the second option. Once you select the second option, you just want to click OK. And then you're going to get another prompt that says everything on this drive is going to be wiped out. Like I said before, you just want to click OK on that. So once you click OK, it's going to start doing this thing. This takes some time because the image is about 1 point something gigs. So it's going to take some time. So you're going to let it do its thing and we're going to come back. Okay, so the installation is complete. So once the installation is complete, you want to remove. So I'm going to go ahead and do that now. You want to remove the USB drive from the computer, and then you want to take this USB drive now and insert it on the device that you want to install TrueNAS on. So we're going to go ahead and do that. Okay, so before we boot the device up, there's a couple of things that we want to do. We want to get into the BIOS for that specific device. In our case, again, it's the AOOSTAR WTR PRO, and we want to change the boot order. So we want to tell it that, hey, don't boot from the NVMe drive that's in there. boot from the USB drive, and then it's going to boot from that USB drive, and then it's going to see TrueNAS, and we're going to be able to install TrueNAS. For the AOOSTAR WTR Pro, you need to press the delete key while the device is booting. So you're going to keep pressing the delete key, and that's going to take you into the BIOS. Okay, so now we're in the BIOS. So what we want to do, you want to go into boot, and then we want to change the boot order. So we're going to go down to boot option number 1. So we're going to scroll down, boot option number 1, and we're going to select that. I've already changed it. So initially it's going to be this guy here. So we want to scroll down and say, hey, we want it to be the USB device instead of the NVMe device that's in there. So once you do that, you're going to go to save and exit, and then you're going to click enter, and it's going to ask you if you want to save those changes. You're going to say yes, I do want to save those changes, and then click enter, and then it's going to boot. So once it boots, it's going to boot into the device. We're going to choose the first one. I'm going to go ahead and say start TrueNAS Scale installation, and it's going to go through the installation process. Okay, so now we're not, it gives us an option that says like, hey, install or upgrade. You go to the shell, reboot the system, or shut down the system. In our case, we want to install. We're not upgrading, so we're just going to go ahead and go to the install option, which is number 1, and click enter. And it's going to show us all of the drives on this device. So as you can see, I have 3 NVMe SSDs, which is 1, 2, 3, and then I have 4 HDD drive, which are 10 TB each. So in our case, like we said earlier, we want to do the installation on the NVMe drive that came with the device, which is this guy. So the other 2 are the crucial NVMe SSD that we installed, we added to the device. So we want to install this guy. So what we want to do, we just want to click enter. We want to go to this guy. Oh, sorry. Just one thing to keep in mind, if you click enter, it's not going to select it. So you want to click space, right? So space select, right? See? So you go to the device that you want to select, click space. It's going to put an asterisk next to that, and that's perfect. That's what we need. And now you can click enter. It's going to take you to the next option. The next option is telling you that, hey, everything on this drive is going to be erased. Again, just keep that in mind. And it's saying that, hey, we advise you to install it on a SATA or on an NVMe, but not on flash drive, which makes sense. And then you say, yeah, that's fine. Click yes. And it's going to tell you here, it's giving you 2 options. It's saying that like, hey, do you want to go with the default admin? And this is something that you can change as well, because you can add new admins once you have the GUI up and running. Or do you want to configure it using the web UI? For now, I'm just going to be like, hey, just set the default admin. That's perfectly fine. And that's something I'm going to change, or try to change as I get into the UI. So I'm going to say number 1 is fine for now, and it's going to ask you to set a password for the admin. So make sure you remember this password, because if you don't, well, you can't get into the device. So in my case, I'm going to make it something simple for now, and then once I'm in there, I'm going to change it. Of course, change the admin and then change the password as well. So let's do that. Hopefully it's the same. Password did not match. Let's see. All right, once you do that, once the password match, you're going to see at the bottom here, if you look at the bottom left here, you're seeing that the installation process has started. It's going to go through its thing. It takes some time to go through the installation process. So once the installation process is done, then it will boot up. But one thing to keep in mind, remember that we made a change in the BIOS to say, hey, boot from option 1, make sure you boot from the USB. So there are a couple of things that you need to do before we restart. 1, you need to remove the USB from the device, so when the computer boot up, it boots directly to the NVMe, or you need to go back into the BIOS and make the change to say, hey, boot from the NVMe instead of the SSD. So make sure you keep that in mind. Okay, so I've removed the USB. I'm going to put that aside, and I'm going to click OK, and I'm going to say reboot the system, and it's going to reboot the system. So once the boot has been completed, it's going to give us an IP address, an internal IP address, to say like, hey, if you hit this IP address, you'll be able to hit the GUI and be able to log in. So we're going to go ahead and try to log into that GUI, or hit this IP address to see if we can log in. Okay, so we hit the IP address that it gives us, and we're able to hit the GUI, so we're looking good. So let's try to see if we can log in. So if I can remember the password. Let's see. Okay, and all right. So remember, this is the username and password that you created when you were creating when you were going through the installation. So make sure you remember that, because if you cannot remember that, then you're not going to be able to get in. So, and that's something that you can change. It on something I'm going to change it myself. Here it tells you your internal IP. So this is your internal IP for this device. You can change it, and again, that's something to me that I'm going to change. So it's going to be changed to static IP, and it's going to be definitely not in that range. So here, let's take a quick walkthrough on the GUI to try to see what we get. Again, these are things that I'm going to dive into every time we work on a new project that's going to be installed on this TrueNAS. These sections, we're going to dive into them a little bit more. For example, today we're going to talk about setting up our storage, of course, because that's one part that I want to knock out of the way. But for now, let's just take a quick walkthrough. So you have your settings in here. We have IX system, which is basically the people that created TrueNAS. So you have a couple of things here. You have the send feedback. You have what is that, status, and then you have running jobs. This is the alerts, and then of course you have the TrueNAS admin and all that stuff. So here is the dashboard. The dashboard looks like this. When you click configure, you can move things around. So if you want to move things, you should be able to do that. And if you want to add a section, you just click add. It gives you a list of sections here that you can add, and you can rearrange your layout as you see fit, right? Pretty cool, pretty nice. One pane of glass to see what's going on with your device. If you come to storage, you have storage here. This is where you create your pool. In our case, we're going to go through that in a minute, but we're going to talk about what these are first before we kind of go through them, so we have a good understanding of it. You have the data set, you have shares, you have data protection. This is where I'm assuming you can back up the data that you have on your TrueNAS to a cloud platform, or do some sort of backup to other things as well, replications and all this other stuff. Pretty cool. You have network, you have credentials, you have users. Here's where the user is, and then you can change that. Again, I'm going to change a lot of this moving forward. You have groups, you have the admin groups and all that stuff, and you have backup. You have backup credentials, and then you have certificates. Virtualization, this is where you add your VMs. Pretty excited to test this out to see what the limitations are and how far I can push it, because there are a couple of things that I need to set up. So, and again, this is one of the reasons why I decided to go with TrueNAS, because again, it just has that all-in-one approach to it. I have my storage here, and if we go back to storage, for example, we go to share, you can create different kind of storage, iSCSI, SMB, Unix, NFS. So you have different set of storage that you can create if you need to. And then you have your virtualization, your VMs that you can create. And then you have your apps. Here's where you will create apps, Docker and all this other cool stuff. So really excited about the things that I'm going to do with this. And then you can create custom ones. And of course, it tells you that you need to create your pool first before you're able to do that. So yeah, you have these things here. You have reporting, and yeah, this is the reporting for the device, kind of the load, the processors, the CPU and all that good stuff. And then you have system settings and all that. So as far as the GUI go, that's pretty much all you get for as far as the installation go. It's kind of the process of installing it. It's not really anything too complicated. So for now, we're going to create our storage pool. Before we do that though, I want us to kind of really get an understanding of what a storage pool is, what are the different type of RAIDs, and all this sort of stuff before we go into creation. So before going into the creation process, so let's talk about those. Okay, so before we start setting up our storage, let's first talk about RAID, because choosing the right RAID setup is super important for both performance and redundancy. Now, one of the things I want to make very clear right now from the start is that RAID is not a backup. A lot of people think that because RAID protect against drive failure, it means their data is safe. That is further from the truth. RAID protect against drive failure, but it won't save you from things like, let's say, accidental file deletion, corruption, or ransomware attack. If a file gets deleted or corrupted, RAID will simply mirror or spread that corruption across all of your drives. That's why you always need a proper backup strategy, preferably with an offsite backup or a cloud backup. All right, so now that we've cleared that up, I had to do a lot of research to try to see what RAIDs are available in TrueNAS. So I'm going to talk about the different RAIDs available in TrueNAS. I'm going to talk about which one I'm going to use, and maybe hopefully you will look at this too and try to figure out which one might be right for you when you're setting up your home lab or setting up some sort of other environments. In TrueNAS, RAID is handled through ZFS, which offers several configurations depending on what you need. To start off, you have Stripe, which is equivalent to RAID 0. You have speed, but you have no redundancy. So ideally what happens is that the data is split across multiple drives for maximum speed, but you have zero redundancy. So if one disk fails, you lose everything. So this is best for high-speed storage where failure really doesn't matter. So things like temp files or scratch disk. So this is definitely not recommended for important data because again, if one drive fails, everything failed. Okay, so next up on the list is Mirror, which is equivalent to RAID 1. So this is full redundancy. Each disk has an exact copy of the data. So if one disk fails, the other one keeps everything intact. This is best for high speed read performance and redundancy. However, the downside is that you lose 50% of your storage capacity. Next up is RAID Z1, similar to RAID 5, which is single parity. It requires at least 3 disks to function. So it uses 1 disk for parity, meaning 1 disk can fail without data loss. This is best for a balance of storage space and redundancy. Now the downside is if a second disk fails before replacing the first one, you lose everything. Next up is RAID Z2. So this is similar to RAID 6. You have double parity. It requires at least 4 disks to work. So it uses 2 disks for parity, meaning up to 2 drives can fail without data loss. So it's best for extra protection when working with larger storage pools. The last one is RAID Z3. So this is triple parity for maximum protection. It requires at least 5 disks in total. It can survive up to 3 drive failure. So it's best for mission critical data where failure is not an option. The downside is that you lose more storage space due to extra parity. Okay, so now that we have a good idea of what RAID is and the different type of RAID that I offer in TrueNAS, what RAID type should you choose? Well, if you want maximum speed, you can go with RAID 0. Stripes, just remember that there's no protection. If you want full redundancy and fast read, you can go with RAID 1. If you want a balance of storage and protection, you can go with RAID Z1. If you want extra protection, you can go with RAID Z2. If you need the highest level of protection, you can go with RAID Z. Okay, so that's pretty much it for the RAID side of things. Now, I also want to break down how TrueNAS look at storage because it might be a little bit different from what you might be used to. It was for me. I had to go do a little bit of research to get a full understanding of how TrueNAS looks at storage. So let's talk about that a little bit more. So in TrueNAS Scale, you have 3 key concepts. You have storage, which are the poles, you have datasets, and then you have share. Let's talk about each one. Storage are the foundation. So think of storage as the physical drives in your system, whether that be HDD drives or SSD drive. These drives are combined into pools using ZFS. The pools determine how your storage is structured, whether that's RAID Z1, RAID Z2, or a different type of setup. Storage pools are the foundation, but you don't just throw files directly into it. And that's where datasets come into play. Datasets help you organize your storage. Datasets is like a folder, but with way more powerful options. Each dataset is a separate file system, meaning it can have its own, let's say, permission, compression, and snapshots. Instead of dumping all of your files into one big pool, datasets help keep things organized, and each dataset can be fine-tuned based on how you want to use it. Shares are how you access your data. So once you've created your dataset, the next step is to make them accessible, and that is where shares come into play. A share lets other devices connect to your datasets over the network. The type of share you use depends on how you want to access your data. For example, you have SMB share, which is perfect for Windows and Mac file sharing. You have NFS share, which works great with Linux system, and then you have iSCSI share for connecting like block storage, which is useful for VMs. To wrap things up, your storage pool holds your data sets organize your data, and then the shares make it easy for you to access your data over the network. Okay, so now I feel like we have a good understanding of all of the components that we need to understand. So for now, what we're going to do, or what I'm going to do, is I'm going to create my storage pool. As I said, I'm going to be creating shares and I'm going to be creating data sets, but not in this video. As time goes on, as we build more things in this environment, we'll talk about those things a lot more. But I'll always reference this video for anyone that wants a better understanding of how those different components work and what they really are. So let's go ahead and set up our pool. Okay, so now that we have a good understanding of all of the components that we need to understand to be able to create a storage pool, but not just create a storage pool, but understand what components is what before we create it. Let's go ahead and create our first storage pool. So for that, we're going to go to storage and we're going to go to create pool. Here, let's start first on the right hand side. On the right hand side, you can see your config here. We don't have anything selected yet, so it's empty. Here, it tells me that I have 9 4 TB drives. So I mean 9 10 TB drives, which is 9.1, right? So I have 4 of those, and then I have 2 SSDs, NVMe SSDs. So remember what we talked about, the 4 HDD drives are going to be used for storage, right? And then the 2, one of which is going to be used for log, and then the other one is going to be used for cache. So as you can see here, you have different configuration: data, log, spare, cache, metadata, dup or deadup, however you pronounce that, and then review. In my case, the sections that I'm going to worry about here: number 1, the name of the storage pool, the data, the log, and then the cache. The rest I'm not too worried about right now. I don't need a spare. Metadata, I don't really need that at this moment. Dup, I don't really need that. Metadata is mostly used if you're accessing small files. I don't see, again, there's so many things that I want to build in this environment. I don't know if I'm going to run into that issue yet, where like I need to be able to access a lot of small files, like a whole bunch of small files, to the point where I'm like, okay, I need something to set up to be able to kind of speed that process up a little bit. So I'm not too worried about that right now. I think data, or however you pronounce that, is used for duplicate. It's used to delete duplicate files. So that's my understanding of it. And again, that's not something I need in this environment right now. So let's go back to general here. So I'm going to call this, and this you can call a storage pool whatever you want. So in my case, I'm just going to call it I'm going to call it Koroma Lab. And again, you can call this whatever you want. This is your storage pool, right? So you can make this encrypted. I'm not actually, I just clicked it for you guys to see it. You can make this you can enable encryption. It tells you, gives you a little bit more information here. I'm not going to do that right now. Go ahead and click next. And this is the storage section. So these are the RAID types that we talked about. So as you can see, we have stripes, we have mirror, we have RAID Z1, RAID Z2, RAID Z3, and we've talked about all of those ones. And then you have this one, right? You have DRAID 1, DRAID 2, DRAID 1, DRAID 2, all of this the three version that you see here. They're the exact same version as up here. The only difference is this ones are used for drive heavy environment. So an environment where you have to set up something where you have a lot of drives. It's designed to be a lot more faster than RAID Z1, but the concept is still the same, right? So you only use it for an environment where you have like huge amount of data to play, a huge amount of storage disks to play with. I only have 4. So, so in my case, I'm gonna go with RAID Z1. And let me explain a little bit why I'm going with that. One, this environment is not a mission critical environment, meaning that I'm not sitting here saying that everything I put here needs to be top of the line, where it's like the drives cannot fail, and if they fail, I'm screwed. It's a lab environment, right? I'm also focused on like I need that storage, so I need that storage, but I also need to have some sort of safety when it comes to my hardware, especially more specifically hard drives. So if one of them was to fail, I'm good. So RAID Z won't allow me to use one out of this 4. It allows me to use one of them for parity. What that means, like we talked about, is that if one of my drive were to fail, right, I can just replace it and everything will be back to normal, right? Now, however, if one drive fail and I do not replace it and another drive fail, then I'm screwed. Again, this goes back to say my environment is not mission critical. So this is something that you have to think about very carefully, not just listen to someone on YouTube that says like, hey, set it up this way and this is the best way to set it up. I don't know if there's a best way to set it up per se. I feel like the best way would be to have like 50-50 ideally, but again, it all depends on the environment that you're setting up. It all depends on you. It all depends on like how important it is for you to be able to replace one drive, 2 drive, or half of your drive if something fail, or how important it is for you for half of your drives to fail and still keep going and be able to replace them. For me, again, I'm okay with one drive failing and replacing it. I need that storage because I'm going to be doing a lot of things in this environment. So that's why I choose RAID Z1. So now if I click here, you can see these my two NVMe SSD, but it's not showing the other ones. So I'm going to go ahead and click manual disk selection. So this is a good time for us to talk about VDEVs. So a VDEV is basically a virtual device that holds all of your hard disk. So my HDD, it holds all of them in one, and it creates a virtual device for things to be stored on. So it will make sense once I click add. So on the top right hand corner, you click add. Right? Now it's telling me that, okay, you created a new VDEV virtual device using RAID Z1. So now I'm going to add my disk to my virtual device. It's not dragging for some reason. You drag it and drop it. You drag it and drop it. And then you drag it and drop it. So if you can see here, it's telling me that like you have about 27.29 usable storage space. Like usable raw capacity, you have about 27.29. Again, that's because this is RAID Z1. That means that I'm losing one of my drives, right, to be able to use this 3. So if any of these 3 fails, anything fails and be like, oh, one of my disks has failed, I can just replace one, right? And then it will be perfectly fine. Now, if one fail, I did not replace it, and another one failed, then I'm screwed. Again, this is not a mission critical environment. So for me, this works. So again, a virtual dev, a VDEV is basically a virtual device that holds all of your storage to create a storage pool. That's what a VDEV is. I don't think I talked about that previously. So that's something to keep in mind. So I'm going to go ahead and say save selection, and I'm going to go ahead and click next. So if you remember, I said that I want one of my SSD to be used for log, and that is to boost the write performance, right? So I'm going to go ahead and select Stripe because again, I only have one. I don't have 2. Again, not a mission critical environment. If it was a mission critical environment, I'd be like, okay, let me just have 2 and then I'll create a mirror and all that stuff, but I do not. For me, I'm just focused on like just having that to increase the write performance, and it's on an SSD. So that works beautifully. So I'm going to go ahead and click Stripe, and I'm going to go ahead and say just one. And it's telling you that like, hey, you just have one of this. If something might happen or something, a power off or something else happen, you might be screwed. Again, this is a dev environment. I know I sound like a broken record, but I don't want you to be setting up things like this, or I don't want someone to go follow my logic and set up things exactly the way I'm setting it up here, thinking that it's okay. Just keep in mind that the reason why I'm setting up the things that I'm setting up the way that I am is because this is my dev environment, and I'm also focused on storage and speed rather than focus on high availability and things like that, right? Just keep that in mind. So that's cool. I'm not so worried about it. As long as I have my SSD, that's fine. I'm going to go ahead and click next. For spare, I don't really care about spare. I don't want to worry about spare. This is if you have one extra drive. For example, let's say I have 5 and I use 4 of my drive to say, use that as use all 4 of my drive in the RAID, and I'm going to use one of the other drive to say, like, if something happened, use this extra drive that's just sitting in the tray, use it as a backup to replace the drive that's damaged. So I don't need that. I don't have that kind of money for a drive to be just sitting there. I'm just kidding. So go ahead and click next. Second, we're going to talk about cache. Again, the cache is to boost performance, and ideally you want your cache to be on an SSD. So again, we have our last SSD, right? So that's why we got 2 SSDs. So as you see here, we don't have any SSD anymore. So we have 1 SSD for log and then 1 SSD for cache. And the reason why we're using the SSDs is because, again, we want things to be super fast. So we have 1, we said use that guy, and then click next. Yep. All right, and then for metadata, again, I'm not too worried about metadata. Metadata is if you're accessing a lot of small file, and metadata is just like a little tiny file that kind of contains an amount of information. But again, I'm not going to be doing that right now. If I reach a point where I feel like I need to do that, then I can come back and then be like, okay, maybe I need to add this to make it work, or maybe I need to get another device that allow me to add that extra to make it work. But I'm not too worried about that right now. Click next. DIT-up or whatever, however you pronounce this. From my understanding of what I've read about it so far, it's used to delete duplicate files. Again, I'm not too worried about that, so I'm going to go ahead and click next. So now we have our storage pool, right? So we have our storage pool, we have our cache, we have our data, which has about 27.29 TB. Good enough space for me to start playing around with things right now. You know, that's a good space. It's a good space. And then you have, of course, the warning about saying that, like, hey, just be careful, because for your log you have Stripe and you only have 1. Again, perfectly fine, right? So I'm gonna go ahead and click create pool, and then again it's telling you the very important message of, like, just make sure that you know that once you click that, anything that's on those data, again in my case this thing is completely empty, it's going to be wiped out. I'm like, okay, that's fine, and I'm gonna click continue. So it's going to go through and then create it, and then we're going to have our first storage pool. So that's the process of creating storage pool, right? But I think what is important is that we have an understanding, because I think for me that's how I learn. I don't just do things, I want to do them to understand, because when I do it to understand, I can build on that knowledge to kind of move me up to the next knowledge to be able to understand concept better, right? So now we have our first storage pool set up. It tells us our storage pool. It tells us what we have in our storage pool. It tells us what we can, what we've installed, or what the usage percentage is, and it tells us everything that we need to know about our storage pool here. So we're good to go. So now you can do things like create data set, like we talked about. You can do things like create share, right? So your data set allows you to organize it like folders, and then you can create share for you to be able to connect to your devices over the network. So as far as everything go, this is where I want to leave it for today. I feel like we've covered a lot of stuff in terms of, like, not just setting things up, but understand how things work, why they work. And I think that's very important. And that's the person that I do want to set for this channel, is that we build things, we understand things, and we break things. But in the effort of breaking it, we don't just kind of like, oh my God, I've set this up. I want to be able to understand each of this concept and be able to kind of go from there, because that's how you build your knowledge. Okay, that's pretty much it, guys. I feel like we have a good understanding of things now. We have the base of our lab environment set up and ready to start building things. But before we actually do, we're going to set this guy up. This is going to be the thing that we're going to use for our firewall. So on our next series of videos, we're going to talk about the Zimmer board. We're going to talk about the board itself, and then we're going to configure pfSense on it and be able to set up something that's going to act as our firewall for our environment, even before we start playing around and building all the components in our environment. So as always, thank you guys for watching. If you haven't done so already, make sure you thumbs up the video if you like it, subscribe if you want to see some more. Yeah, and I'll see you guys in the next one. Peace.